Hi there, folks. Today we're going to start looking at the relationship between lines and angles and the different types of lines that we have and the different kinds of angles and relationships that they form. So, first of all, parallel lines, you should already have a conceptual understanding of parallel lines as lines that never intersect. But with geometry, we have to be a little bit more specific. They're actually coplanar lines that never intersect. Okay. We have another type of lines that don't intersect, but they're basically not on the same plane. All right, so skew lines are the ones that are non-coplanar lines that never intersect. All right, and we'll see an example of those in a second. It's kind of hard to describe when we're just kind of talking about it or trying to show it here because once we get into skew lines, we have to start thinking in terms of 3 dimensions. All right, parallel lines, if I drew 2 lines that don't intersect on a piece of paper, those are parallel. All right, but if I have 2 separate pieces of paper and I have a line drawn on each, well, those lines are never going to intersect, but they're not necessarily parallel, okay? And then parallel planes are planes that never intersect. Remember, planes, just like lines, extend forever in every direction. If you almost kind of think of like shelves on a bookshelf, each of the shelves should be a parallel plane, all right? The entire flat surface should be parallel to the other entire flat surface, all right? For example, if I look at these guys, so here's kind of an example where it's drawn almost like bookshelves. So I have plane P and plane Q, and those are kind of one above another. You have to kind of imagine it that way. And you can think of like SR and TV as kind of like the support joists that are keeping those shelves together, something like that. And so as we start to look at this, name a pair of parallel lines. So for this one, for them to be parallel, they have to never intersect, all right, but they have to be on the same plane. So when you look at something like this guy, RV and line L are probably the best candidates for this. So line RV. Oh, and I should just use the symbol for parallel lines. We say RV is parallel to line L, okay? There is one other set that appears to be parallel. We couldn't necessarily technically prove it because we don't have enough information, but we're going to assume that these are parallel. But if you look at line SR and TV as well, and once again, even though there's not a plane drawn through those two appear to be parallel. There is a plane that exists through all of them. Okay, that plane is not drawn. If I were to draw that plane right here, kind of be as almost like the edges of that plane. It's kind of the plane that's kind of going up and down through there. And even though that plane isn't drawn, it doesn't mean that it doesn't exist. So please keep that in mind. All right, those could be coplanar. Skew lines, and again, if we kind of think of one of those green pieces floating above the other piece, something like line M and line L would be skew lines. See, they're not parallel. They're not running side by side like parallel lines normally do, but they're also never going to intersect. One of those lines is floating above the other line, all right? And so even though they'll never intersect, they're not parallel. They're skew lines, all right? So line M and line L. Okay, you could also say something like line M and line RV, all right, or even line M and line TV, all right. So they'll never intersect, but they're also not parallel. Pair of parallel planes. We can kind of see this from the picture, and as we look at these, if the green pieces are like shelves, one another above another, we would have plane P and, of course, plane Q, the only 2 planes drawn at the moment. That doesn't mean that other planes don't exist, all right? We just only see those 2 as being parallel. And then name the intersection, the intersecting planes. So here you have to think outside the box a little bit, because when we look at this, it appears that the only 2 planes drawn, well, they don't intersect, okay? But remember, planes exist all over the place, all right? Even if they're not drawn, they still exist. So I could say something like plane Q would intersect with plane, how about SRV? And that was the plane I drew earlier, that kind of diagonal one that runs vertically up and down. Again, that plane is not drawn, but it still exists, all right? And it intersects with plane Q. It would also intersect with plane P as well, okay? Let's talk about a transversal. A transversal is basically a line that intersects two or more other lines, okay? Two or more other coplanar lines. And so when we're talking about these, we're not going to be dealing with different planes when we're talking about the relationship between these angles. So two lines get cut by another line. That line that touches each of them is the transversal, all right? And so in this particular example, we can see we've got 3 lines drawn, and we need to know which one of these is the transversal. And so again, look back at that definition. It's the line that intersects the other lines. So if we look at this, the line that's kind of doing the intersecting, that's running into all the other lines, is line M. Okay? So that's our transversal, is line M. Okay? So now what happens is when we have a transversal, notice we've formed a bunch of angles here. And I've labeled them as 1, 2, 3, 4, 5, 6, 7, 8. And these angles have special names, all right? When there's angles that are formed by a transversal, a line that intersects other lines, we have special names for them. First of all is the interior angles. The interior angles are the ones that are in between the lines that are being intersected. So in this case, the lines being intersected are lines J and L. So the interior angles are the ones that are in between J and L, all right? So something like angle 3, angle 4, angle 5, okay? So these would be our interior angles, okay? The ones that are in between the two lines. And then exterior angles are the ones that are outside of that area, okay? They're not in between, they're outside the two lines being intersected. So if we kind of think of it that way, as in between is inside, not in between is outside. So exterior angles would be 1, 2, 7, and 8. And again, that's a really easy concept as long as we understand which lines are the lines being intersected and which line is the transversal, okay? The transversal is the line that's running into the other lines, and then interior is in between the intersected lines, exterior is outside the intersected lines, okay? So angle pairs formed by a transversal, not only are we talking about interior and exterior, but some of these have special names in terms of their position based on the intersected line in the transversal. So the first one is corresponding angles. Corresponding angles are basically angles that are in the same spot. So like when we look at this, we see that here I have the same example as we did on the previous page. I've got the transversal M. If we were to kind of take a snapshot of each of those intersections, like right here, if I were to take a snapshot of these angles and then a snapshot separately of these angles, and I compared those pictures, so I put a little box around them, imagine those as little pictures, little snippets, as it were, which angles would be in the same spots. All right, that's basically what corresponding angles are. So if I look at that first picture, that top picture with 1, 2, 3, 4, I've got a 1 in the upper left-hand corner. And when I look at the other picture, the 5, 6, 7, 8, I have a 5 in the upper left-hand corner. Those two angles are the same position. They're in the same spot on my picture. So those are corresponding angles. Okay? So an example of corresponding angles would be angle 1 and angle 5. Okay? Again, if I looked at that first group, up in the upper right-hand corner, I have angle 2. When I look at the second picture, the upper right-hand corner has the angle 6. So those are corresponding angles. All right. And if I kind of just keep matching these up, angle 3 is in the same spot as angle 7. Angle 4 is in the same spot as angle 8. All right. It's just visually, are they in the same spot? Are they in the same position? All right. And so again, down here, I'm looking at this corner, and now I'm looking at this corner. Oh, those are in the same spot. When I take a picture of each of those groups of angles, those are corresponding angles, okay? The next one, alternate interior angles. First of all, the interior should be a little bit of a giveaway here. Interior means that they're interior angles. They're angles that are in between the lines being intersected. But alternate is referring to the transversal. Alternate means they're on different sides. Remember, when you alternate, you go back and forth between different things. So alternate means they're on different sides of the transversal, and interior means they're inside the two lines. So alternate interior. So when you look at something like this guy, if I were to look at any interior angle, so the first interior angle I see is angle 3. So angle 3 is an interior angle. The alternate interior angle, all right, the other angle that's on the other side of the transversal, and here's the key, that's non-adjacent to that, would be angle 6. It's essentially the angle that's furthest from angle 3 on the other side, okay? And then, again, if I were to look at something like angle 4, the alternate interior angle would be angle 5. See, and again, we're trying to look at the relationship between one group and the other. I don't care about 3 and 4, all right? Yeah, they're both interior angles, but they're already something special. They're already a linear pair, all right? And so when we're looking at this, I'm trying to compare the group with 1 through 4 to the group with 5 through 8, all right? So all of these are going to correspond to the other group, all right? So corresponding angles are in the same spot. Alternate interior angles, non-adjacent, they're interior angles on opposite sides of the transversal. And then same side interior angles, hopefully you can take a guess at what this is. This is the same thing, except they're on the same side of the transversal instead of being alternate. So again, if I started with angle 3, the angle in the other group that's on the same side of the transversal and is an interior angle would be angle 5. And then once again, if I looked at angle 4, the same side interior angle would be angle 6. Okay? So again, we're just comparing these things. We have special names for each of these different angle pairs. All right? And there's nothing really special about those at the moment, but we'll see special things happen with those when we start to look at things like parallel lines and those kind of things. But we need to understand which angles are which at this point. And now we're up to alternate exterior angles. You can probably take a guess without even reading this thing what this is. It's the same as alternate interior angles, except now we're looking at alternate exterior. So once again, they're non-adjacent exterior angles, so they're non-adjacent, but they're exterior angles this time on the opposite sides of the transversal. And so for this one, if I were to look at something like angle 1 is the first exterior angle I see. When I look at the other group, the exterior angle that's on the other side of the transversal is angle 8. Okay? And this is why it was important for us to understand, like, what does exterior, what does interior mean? All right? Because now these should be easy. If you know what alternate means, all right, and you know what an exterior angle is, these shouldn't be too hard to pair up. Angle 2, the alternate exterior angle. So I look at the other group and say, okay, which exterior angle is on the opposite side of the transversal? Well, that would be angle 7. Okay? And so we're just describing the names of these angle pairs. We'll find out that there's situations in which these angle pairs have special relationships as well. Okay? If I look at something like this guy, once again, it asks me to first state which one of these is the transversal. So which line is intersecting the other line? So notice I don't have anything color coordinated this time to make it easier. I have in the previous couple examples. But this one, the transversal, the line that's intersecting the other lines would be line L. All right, it's just turned sideways this time. And so now if line L is the one intersecting things, I have to say, okay, the lines being intersected, look at the angles inside and look at the angles outside, all right? Hopefully you can see which ones are in between those two lines and which ones are not in between. So now it says name an alternate interior angle to angle 5. So here's angle 5. That's an interior angle, so I look at the interior angles from the other group. That's 2 and 4. Alternate interior means the one on the other side, so that would be angle 4, okay? The next one says name the corresponding angle to angle 3. So that's the one that's in the same spot. So again, we're taking a snapshot. Here's a snapshot of this. Here's a snapshot of this. Angle 3 is the one that's kind of down and to the left. So when I look at the other group, the one that's down and to the left is angle 7. So again, corresponding just means they're in the same spot. The next one, same side interior to angle 4. So once again, angle 4 is an interior angle. When I look at the other interior angles, if I look at that other group, the interior angles are 5 and 7. So the question is, same side interior, which one of those is on the same side as angle 4? Well, that's angle 7. Okay. And then this one, name an alternate exterior angle to angle 8. So once again, angle 8 is on the outside. So look at the other group. The ones that are on the outside are angles 1 and 3. But I want the alternate exterior, so I have to look and say which one's on the other side of the transversal. Well, that would be angle 1. Okay? So again, a transversal is a line that intersects 2 or more lines, and it forms these special angle pairs, all right? We have different names for them. Remember, the angles that are in between the two lines being intersected are interior. The ones on the outside are exterior, okay? And then that word alternate means on opposite sides of the transversal. Same side means on the same side of the transversal. Corresponding, take a snapshot of each and say which ones are in the same spot, okay?